When we try to extract useful facts from modern information environments, we face an immediate problem of scale. The volume and variety of the documents we encounter overwhelm our standard reading habits. For decades, mainstream cognitive psychology has studied reading comprehension by isolating it. Researchers place a subject in a controlled laboratory, hand them a single, simplified text, and ask them to read it from start to finish. This controlled approach produced the classical situation model. It suggests that a skilled reader decodes words sequentially, uses causal markers to map the connections between events, and ultimately builds a single coherent mental image of the narrative. That model accurately describes reading a novel or a single essay, but it breaks down the moment we leave the laboratory. In naturalistic settings, whether at a university library or an office desk, readers do not read one text at a time. They navigate a heterogeneous array of catalogs, databases, news articles, and primary source documents, often simultaneously. The end goal in these environments is rarely to comprehend a single text linearly. A reader usually has a pre-existing problem to solve, and they scan across multiple sources strictly to extract the specific data required to fix it. To understand how humans actually process this chaos, cognitive psychology requires an updated framework. We call this functional literacy. Mastering text comprehension does not guarantee functional literacy. In practice, the two rely on separate cognitive skill sets. Being highly skilled at building a mental model of a single story does not mean you can effectively navigate a network of documents. To map the shift from the traditional reading model to this generalized model of functional literacy, we must examine the process across three specific dimensions: the text, the reader, and the context. Treating modern multi-document research as a simple reading task guarantees cognitive overload. Navigating these arrays is a distinct psychological activity, requiring an entirely different set of mental tools. We begin by redefining the material we are reading. This matrix outlines our updated cognitive model, starting with the first dimension, text. Under the restricted view on the left, researchers analyze micro-level features. They look at a document's lexical content, the specific vocabulary, and the localized sentence structure to measure difficulty. The generalized view on the right shifts the focus to macro-level features. Here, a text is not treated as a transparent window into meaning. It is recognized as an artifact, a designed object built by a specific author to convey a specific communicative intent. As an artifact, the text utilizes physical and digital content representation devices. Paragraph formatting, digital interface menus, and typographic headings exist specifically to guide a reader's search strategy before they read a single sentence. The most critical macro-level data points are the source features. These include the author's credentials, the publisher's reputation, and the exact timestamp of publication. Look at this comparison. We have two identical academic documents. If one is stamped 1905 and the other is stamped 2005, an experienced researcher reads them with completely different perspectives. The date alone dictates the validity of the claims, regardless of the actual vocabulary used. Experienced readers process these source features to qualify and filter the semantic content before any deep reading occurs. In a multi-document world, what a text physically represents as an artifact is equal in importance to what its sentences actually say. We move down to the second dimension of the matrix, the reader. The restricted view defines the reader purely as an information processor, passively attempting to translate incoming words into stable mental models. This processor model contains strict inherent bottlenecks. If a text vocabulary exceeds the reader's verbal decoding skills, or if the causal links exceed their working memory limits, comprehension breaks down entirely. The generalized view redefines the reader as the literate agent. A literate agent possesses meta-knowledge about the reading process itself. They know that no document is neutral, and they actively scan for the underlying intent of the author. To manage conflicting information, the literate agent deploys a specific cognitive mechanism called the sourcing heuristic. When faced with two contradictory claims, the brain uses this heuristic to evaluate the origin of the texts. It checks the author and date, allowing the reader to quickly discard untrustworthy claims without wasting cognitive energy on deep semantic analysis. This is the primary tool literate agents use to resolve the contradictions that arise when synthesizing different sources. This rapid arbitration relies entirely on macro-level features. You cannot evaluate a source if you don't know how to read the artifact. The literate agent operates a level above the semantic text. They interrogate the credibility of the physical artifact to decide if the sentences are even worth decoding. This leads to the third and final dimension of our updated model: context and task. The laboratory context relies on content-oriented tasks. The reader's only goal is to process the passage for short-term retention, to pass a concurrent or delayed memory test. Naturalistic tasks are purpose-oriented. The reader approaches the text with highly specific pre-existing information needs, like locating a strict definition or a specific historical date. This environment demands a specific purpose-oriented mechanism: information search. Holding a specific search objective firmly in working memory while scanning dense pages of text is a severe cognitive demand. The incoming sentences constantly threaten to overwrite the original goal. To protect that search objective, the brain must actively deploy inhibition mechanisms, continuously filtering out irrelevant text noise. A second purpose-oriented mechanism is document integration. This requires the reader to simultaneously track source representations, who wrote the text, and link them directly to content representations, what the text actually claims, across multiple competing documents. Document integration taxes working memory so heavily that it serves as the primary dividing line between novice students and expert literate agents. In naturalistic environments, reading is an active exercise in memory control, goal maintenance, and cognitive inhibition. With the text, reader, and context redefined, we can establish the operational end state of functional literacy. We must dispel a major misconception from legacy reading models. Everyday reading rarely requires a human to construct a fully integrated, holistic mental model of a text's total meaning. The true functional objective is narrower. It requires mapping isolated fragments of text onto a pre-existing mental representation of a problem until the missing data is slotted precisely into place. Achieving this specific mapping requires 3 strict cognitive prerequisites. Prerequisite 1, a mastery of declarative and procedural knowledge regarding visual and verbal cues. The reader must know how to navigate the architecture of the artifact, not just the words printed on it. Prerequisite 2, the habitual application of source corroboration. A reader must evaluate credibility through metadata before they allow the information to integrate into their understanding. Prerequisite 3, advanced memory control mechanisms. The brain must possess the capacity to sustain a strict search objective while ruthlessly inhibiting irrelevant noise. These 3 prerequisites determine whether a reader can successfully utilize the resources of a complex digital information landscape. This framework provides an actionable mandate. Designers of educational curricula and human-computer interfaces must build systems that explicitly support goal maintenance and source evaluation. Optimizing our systems purely for semantic comprehension is a relic of the laboratory. The future requires interfaces and training that support literate agents as they navigate complex, heterogeneous document networks.